Here is a fact that most PLC training courses skip. The technician who gets called first when a line goes down earns more than the one who only programs. Fault diagnosis is the highest paid skill in controls work. Not because it is rare, but because stopping downtime costs real money and the people who stop it fastest are worth the most. This video gives you the tools to be that person. You will get the 7-step systematic method that moves from symptom to root cause in the fewest steps. You will see all 4 fault families and learn to identify which one you are in before you touch anything. Then you will watch a broken seal-in fault diagnosed live in the free browser simulator at plcsimulationsoftware.com. Symptom to ladder trace to fix to passing tests, under 2 minutes. The method first. 7 steps. Senior techs follow this sequence on every shift, not because they memorized it, but because random probing wastes time and can create new faults. Step 1. Define the symptom precisely before touching anything. Write it down. Motor does not start is a symptom. I think the proximity sensor is bad is a hypothesis. Keep them separate. Step 2. Confirm power. PLC in run mode, I/O card power LEDs on, no fault lights, supply voltage at the distribution point. A PLC in fault mode or a card with a blown supply fuse mimics a dozen other problems. Step 3. Read the ladder. Open the online ladder monitor and find the output coil for the device that is not operating. Walk the rung left to right. Which contact is false when it should be true? That contact is your target. Step 4. Check inputs at the I/O card LED. For the blocking contact, find the input LED on the physical card. LED off means the field device is not operating. Go trace the field wiring. LED on but tag false means a configuration fault, wrong tag address, or wrong card slot. LED matches the tag, but the rung is still false means the fault is in the logic of the rung itself. That LED to tag comparison is the fastest split between a field fault and a software fault in the whole method. Step 5. Half split the field wiring. Measure voltage at the I/O card terminal. Voltage present, trace toward the device, measuring at the midpoint of the remaining run. 0 volts, trace back toward the supply. Each measurement has the fault window. 16 components for measurements maximum versus 16 sequential tests from one end. Step 6. Check the output card and field actuator. Output LED lit, but actuator not responding means a break between the card and the actuator, or the actuator itself has failed. Output LED not lit, but the tag is true means the card fuse is blown or the card has failed. Measure voltage at the actuator terminals while the output is commanded on. Step 7. Apply the fix and verify. Make the minimum change needed. Clear all test forces. Cycle the machine through a full operational sequence. Confirm the original symptom is gone and no new symptoms appear. Document root cause and fix in the maintenance log. Never close a job without verifying. Before any diagnosis, identify which fault family you are in. This determines your first measurement and the correct tool. Family 1. Wiring faults. 60 to 70% of field calls. Broken wires, open circuits, transposed terminals, corroded connections. The symptom is an input that never changes state even though the field device is operating. First check is supply voltage at the device, then continuity back to the card terminal. Tool, multimeter. Family 2. Configuration faults. The input changes in the field, but the PLC ignores it. Or a temperature reading shows 2000 degrees instead of 200. Wrong tag address, wrong I/O card slot assignment, bad scaling block. First check is the software, tag addresses, card slot configuration, scaling parameters. Tool, software monitor. Family 3. Logic faults. The rung stays false even when all inputs appear correct. Wrong contact type. A normally open contact where a normally closed contact should be, or vice versa. Missing seal-in branch. Wrong coil address. First check is the contact types and the rung conditions in the ladder monitor. Tool, ladder monitor. Family 4. Intermittent faults. The fault clears itself, reappears under load, heat, or vibration. Electrical noise, thermal expansion, moving a loose connection, vibration loosened terminals. First check is connector seating and shielding. Tool, multimeter plus data logging over time. This last family is the hardest because it is not present when you look for it. Match your symptom to the right family before you pick up any tool. Now the live diagnosis. The fault is a broken sealant. Here is the scenario. The motor starts when the start button is held, but drops out the moment the button is released. Field wiring has been verified correct. Step 1. Define the symptom. Motor starts on held start button, fails to latch. Step 2. Power confirmed. PLC is running. Step 3. Read the ladder. Watch the rung in the simulator. With start button held, the rung goes true. Release the button, the rung goes false immediately. The output coil de-energizes. Step 4. Check inputs. The start button input LED is correct. The stop button is correct. The contacts read what the field is doing. So the fault is not a wiring fault. It is a logic fault. The rung goes false because there is no holding path. In a standard 3-wire circuit, the motor contactor has an auxiliary normally open contact in parallel with the start button. That contact keeps the rung latched after the start button returns to rest. That parallel branch is missing. Without it, the only path through the rung closes with the start button and opens when it releases. Step 5 and 6 do not apply. We are already in the logic. The fault family is confirmed. Logic fault, missing sealant branch. The fix is 1 rung edit. Add a motor_contactor normally open contact in parallel with start_PB. That creates the self-holding path. The contactor closes, its auxiliary contact closes in parallel, and the rung stays true regardless of the start button state. In the simulator editor, select the rung. Add a parallel branch. Place a normally open motor_contactor contact. Connect it in parallel with start_PB. Click Run and test. Press the start button momentarily. Release it. The contactor stays energized. The motor seals in. Press Stop. The contactor drops out. The motor stops. Switch to the test panel and run the autograder. 2 test cases. Motor seals in after start is released, and stop drops the contactor. Both pass. Green across the board. The fix took 1 contact. The diagnosis took 4 steps. That is what a systematic method gives you. Speed through structure, not speed through luck. The training track includes 16 fault scenarios and wiring labs. You can find it at plcsimulationsoftware.com. 8 fault scenarios cover the full range. The normally open/normally closed swap. The broken seal-in you just saw. A wrong tag address. A stuck input. A scan order race condition. A timer not resetting. A counter overflow. And an intermittent edge case. 8 wiring fault labs cover field circuit faults. Photoeye polarity. Relay contact swap. Rail short at the terminal block. Broken supply wire. Broken return wire to a contactor. Broken sensor signal wire. NPN photoeye polarity. And a relay alarm stuck on. Every scenario injects a specific fault into a running machine simulation. Every wiring lab puts a fault in a field circuit and asks you to trace it with a virtual multimeter. Every one is auto-graded. The first 2 fault scenarios are free. No account needed to start. That is the complete framework. The 7-step method, symptom, power, ladder, I/O card LED, half-split wiring, output card, verify. The 4 fault families, wiring, configuration, logic, intermittent. And the habit that separates experienced technicians from beginners. Define the symptom before you form a hypothesis, and follow the method before you touch anything. The full PLC troubleshooting training track is free to start at plcsimulationsoftware.com/plc-troubleshooting. Link is in the description. If this gave you a clear fault diagnosis framework, subscribe. The next video covers Studio 5000 ladder logic with real practice rungs you can edit in the browser. See you there.